monitoring system. And here we have a solar battery charging monitoring system. We have the proven background, proven statement, aim of the project. We have um, we have the project background, and we have project objectives, and we have the application requirements. So let's get into the video.
Good day, everyone. My name is Suleiman Nidaku Akotua, and in our group, we are creating a solar battery charging monitor system. And I'm here to present to you the what I and my colleagues created in this group. So basically, I'm the GitHub manager here. So I created the GitHub account and I created a repository and I uploaded the files some of my colleagues created. So here we can see we have the pseudo code, we have the problem statement and objectives, we have the readme which I also created, and we have the solar battery report, we have the algorithm, we have the flowchart and the solar battery report. Okay, so here are some of the collaborators we have here. We have only three collaborators because not all of us have the GitHub account. So we have Godfred here, we have Elijah here, we have Suleiman here. So the video continues as my colleagues also explain their part they took. Thank you.
Good day, everyone. My name is Adro Elijah Labi, and I'll be presenting the problem statement and objective of our project, the solar battery charger monitor system. I have quite stated a number of points in our report, but I would love to make it in a brief for better understanding. In many homes and farms in Ghana, our solar energy is used, but people cannot monitor the battery health. This leads to overcharging, deep discharge, and early battery failure. So our main objective in the group is to design a system that monitors, displays, and protects the solar battery. Specifically, we will measure voltage, current, calculate the battery percentage, displays the data, and provide automatic safety protection. Thank you very much.
Hi, I'm Japan Godfred, and I'll be taking you through the algorithm and the flowchart. So here is the algorithm. Algorithm is the step-by-step procedure using to solving the problem. And these are the same method we used in writing the code also. So here are the step by step algorithm, and it start from the step one. You start the program, and then you display the title. You ask the user to enter the battery identification number. Ask the user to enter the rated battery voltage. Ask the user to enter the measured charging voltage, and you continue from there to the last part of it, which is the end, the program. So I will continue with the flowchart also. So the flowchart, this is the symbolical representation of the algorithm. So from here we can see it has different types of shape, which starts with the oval that can represent the end, sorry, the start or the end button. And we can see rectangle, we can see parallelogram, and we can see diamond shapes also. So the diamond shapes, the parallelogram, and then the rectangle, the diamond shapes, which also talks about if there is a decision making, and we can see arrows also that is connecting them together, and then at the end we can see the end that also is in the oval shape. So this are the algorithm and then the flowchart. Okay, thank you.
Hi, I'm Moini Akim and I'm presenting on pseudocode. So this is a simple program for monitoring a solar battery charging system. Number one, input the system. Input the system asks for battery ID, rated voltage, charging current, charging duration. Number two, check if any value is negative. It shows invalid reading and stops. 3. Calculations. If inputs are valid, charging power will be equal to charging voltage times charging current. Energy supplied will be equal to charging power times charging duration. 4. Charging status. Low charging is to if charging voltage, rated voltage. Normal charging is to if charging voltage is up to rated voltage plus 2. And next point, high charging warning is to if charging voltage is too high. Number 5, output. It displays all inputs, calculated power and energy, and the status. 6. Final steps. Final step saves the full report to a file. It's a basic solar charger monitor inputs that validates inputs, calculates power and energy, checks if charging is normal or not, show results and save reports.
Hi, my name is Ejapon Godfrey, and I'm responsible for the C++. So this is my C++ implementation of my solar battery charging monitor. So I use the IO stream for user input, and then the F stream to save the report to the test file. The IO man to format the output. I created a solar battery class to organize the battery data and function. The program accepts the battery ID, the voltage, current, and then the charging duration. Then it calculates the charging power and energy supply. It also determines whether the battery is under charging, or normally charging or overcharge. And finally, it displays the charging report to the screen, save it as a test file, and then the main function controls the overall execute of the program. So after doing this, this is how my solar battery report shows.